Okay. So, basically, this hopefully will be quick. So, my video game, right? Why is this wizard? Basically, I need to do some math. It's basically for lore reasons, you see. I can't forget the meowing. For lore reasons. So let me see what I can do here. We see that the vertical components of all the points here will be cancelled out by the opposing one. So we can just worry about the horizontal distance, right? You put Sharky in the box? Okay. Whee! So... And... Okay, Okay. Having to meow is really throwing off my thought patterns. Okay, no. So, maybe I will. Um... So, when does it go to your strive time? Hopefully soon. I just really want to finish this problem first. Nerd, I'm sorry. So we have R for the radius of the circle. It's cute. It's not cute. So, let me see. No, no, no. We might instead... Well, no. The coordinate system I set here might be terrible, actually. But that's fine. So... In fact, so the mass of... Golly. I need to find out the mass of this disk, right? We know that... the mass of the whole thing is going to be... hang on. 5.97 over 2 is 2.985, which will just round to 2.99. Return to the 24th. Alright, so... Not speaking to me like I understand any of this. I'm speaking just in general, right? Cause, yeah. So, oof. You know. You're being silly. Fair email. So the mass of a disk. Silly Timmy. We are making the assumption that the density is uniform, which it's not, but that doesn't matter. What we need is to know... Because, like, obviously mass, the amount of mass decreases as you go there, right? So, here, let's look up, well... So, we know that, equals... I guess from... We can kind of pretend it's the flipped around version. So we'd go 2391.75 up to 3986.25. Right? Right. It's a weird way of doing that. Hang on. Let's actually just do it, so from 0 to 6378. That makes more sense. And the volume of a disk is pi r squared w, okay? And delta x here is the width, so we can put d with respect to x. Pi can come out to the front because it's a constant. Then r. I guess we can say that, so let me fix up this terrible thing I have here. I'm going to get a better one. Okay, hang on, let's just bring this whole thing with it. Whoops. There we go. Now I can move it. So we can say that r equals, so yeah, the radius is going to be x squared plus y squared, right? I'm gonna have to assume how much you like doing some math stuff because you've been toying with an idea to help out. Okie dokie. Right now, it's because it's for a project. I would explain, but I don't want to waste too much time. So, r equals x squared plus y, or r squared equals x squared plus y squared. And then, let me think. Because the y value also changes as you move, huh? So let me... So, we're moving with respect to x. So maybe... But wait. Wouldn't y here always be equal to the radius? No. Because we need to be... hang on. Here's a formula here, just to help out. It says delta x times pi r squared is correct, okay. Here. The solid consists of adjacent vertical disks, pi from A to B, r of x, where's r of x? Is the top minus the bottom. Hang on. Oh, okay. The thing is, though, we actually... So we already know what the... Hang on, what am I up to? Because it's tricky. We already know what the volume of this thing is, right? Well, we'll leave this here. We'll leave the number there anyway. I'm actually already on the eraser. We have the volume there. Or not the volume. This is the mass. And then the volume of a hemisphere. So, grr. Two-thirds fire cubed. So 2 pi r cubed is the volume of the hemisphere. Sure. Let me see. Oh, we'll leave that in, I guess. Volume of a cylinder is because a disk is basically a cylinder, right? When you make it small enough, equals pi r squared. I guess that's still delta x, okay. I guess the radius is what depends on... The radius depends, don't really care about... in disk volume integral, so let's see. Disk integration. Pi times f of x. I guess, I mean, am I allowed to rewrite it as y equals, or yeah, y equals square root of r squared minus x squared? Because, if we write that the mass of the object hang on, so density, what's density? Density is mass over volume, right? So if we, so E equals m over v, therefore, mass, which we have in its own, so, so mass times density equals volume, wait, no. You multiply volume on both sides, so it's volume times density equals mass. Alright. And we already know the density, right? But this isn't helpful. Not exactly, anyway. So I need to know the mass of a disk. Oh wait, if we're solving for... Okay. So we don't know the mass of this disk, right? So we have our formula for the volume there. So we can write pi times radius squared delta x times the density, which is 5,515 kilograms per meters cubed. Right? Alright, so we have this. equals the mass. Okay. So now we have hang on, we have the integral we're after basically. 5 times 5, 515 r squared delta x. Not delta x, it's dx there. Is that correct? No, because we have to solve for... Because we want that it's in respect to x and we have an r there, so that doesn't work quite. R equals square root of x squared plus y squared, right? We don't want to be nesting those like that, so that's not good. So, R is usually... So R is the, like, point on the function, right? Technically speaking, we could just deal with... So... Hang on, that is... Yeah, that's the correct... 5 times 515 times, 0, from 0 to 6378. And then... we need to solve for y. Oh, I know. So look, if you have your circle, right, you have your point here. Then if you go just to an arbitrary radius like this, you can make yourself a right triangle. You can say that's theta, y equals sine of theta. Wonderful. Okay. In fact, even better, you can say y equals, because sine of an angle is equal to the opposite over the hypotenuse. So actually, it's not y equals sine theta, it's that y over r equals sine theta. And we care about what y is here. So we'll multiply r across, so it's y equals r sine theta. Alright. So now we can replace this here, the y. So r equals square root of x squared plus r sine theta squared. Okay? So that's good. Then it's squared for this formula, so the square root would go away. So we'd have x squared plus r sine theta squared, or r squared sine theta squared. Is that correct? We've solved for y, we've... Oh, except... Hang on. No, because we're trying to put this in terms of x, right? So, we'll just put this back. So it's r squared equals x squared plus r squared sine theta squared. Yeah, so we can carry this over. So it's r squared times 1 plus sine theta. Wait, that's still sine squared, isn't it? Yeah, because I factored that. Okay. Equals x squared. 1 plus sine squared is cosine squared. awesome, equals x squared. So we can say then that r squared equals x squared over cosine squared theta, which is good. Yes. And then so then we look over here again. We have our theta here. X over r equals cosine theta. And wait, we want just r. No, actually we don't care about getting just r because we're doing it with respect to r squared anyway. But that might be as good as we can get right now. If we do x squared over cosine squared theta, well, with respect to x, see, now I'm still confused because we've got a theta in there. I guess we could say that no, but anyways, we have our, so 1 over cosine squared is secant squared, so we can, that's 6378. So that's secant squared theta times x squared with respect to x. So this is the integral I'd like to solve. It's just that I do need to solve for theta. So, because we, I guess we could say that theta equals the inverse cosine of x over r, right? But then, if we put that in there for this theta, we'd basically just be saying x over r equals x over r, right? So I'm not quite sure what I meant to do. Hi, Timmy. Sorry to waste y'all's time with this, golly. So you have your delta x, f of x at point I, right? So yeah. It's just that we could instead put, or try to put x in terms of theta. Right? Which could possibly work better. Because we have... no, I don't know. Okay, well... Okay. Hang on, maybe I'm going about this wrong. We already have the... We'll leave this part here. But maybe I don't need to be actually doing integrals. Not cute, Grace, you silly. But because we have the mass is the volume times the density. Maybe we just like puzzle this out, you know? Because no, neither you are correct. You forgot the other one? What other one? There is no other one. There's pi times x squared over cosine squared theta times delta x, right? Cat is not a thing. And then we can multiply this by 5.515 kilograms per meters cubed equals the mass. Oh wait, hang on. Times delta x equals the mass. No, you silly. But yeah, I just need to figure out like what theta would be in terms of x. Is there a way I can figure that out? I mean, I guess technically speaking, so actually the radius is always just the value of y, isn't it? So maybe we'll just make that assumption. Right? So if y is r, then we would be able to say, I mean, then the sign of because then we'd have 2r squared. Wait, no, that makes no sense. I think I'm like on the right track, you know? I'm wasting so much time with this. Let's see. Maybe I have... No, not adorable, you silly Grace. Hang on, one second. I think this book here has been... Oh golly, it's falling apart. I think it's got my calculus notes in it from last time I tried taking this. Golly. Maybe before there? Golly. Is this... Oh, that's rates of change, I think. 12, okay, here. So... Where... Well, okay, so... Here. Um... My. So, golly. Oh wait, I see what it's saying here. So the height of a disc, like from the distance from one side to the other, is 2y, right? And then maybe I'm misunderstanding. I don't think that's relevant. I might be looking at the wrong problem. Because I'm sure that we went over a similar problem at one point in the class, right? Okay, this is almost something. That's okay. Let me think. Put the book back where it was. Not helping. Okay, so the volume of a disc. Get rid of all this. So we instead say that this is y, right? Maybe. So, from one side to the other is 6,378. And then, if we have our thing, right? Then if we, like, shaved off a delta x, then mass of it, well, mass, so this is, oh, hi! New to Dinosaur XL. I hope you're having a good evening. I've been meaning to switch to Guilty Gear for a while now. I've just been having an eensy-beensy amount of trouble with my little math problem that I gave myself, essentially. So, volume here. Hang on, I don't know how much of this is actually correct. Here, let's see. The volume of a sphere is 4/3 pi r cubed. So that would be 2/3 pi r cubed times the density, which is 5515. kilograms per meters cubed. Okay. So, we'll say that x equals, so x is the weight we're looking for, right? X is the mass. Or maybe not x as our variable, we'll just choose like, I don't know, smile. Smiley face equals, let's see. So, 2.99 times 10 to the 24th minus smile, we'll just do like a colored in dot, I guess, I don't know. So, the weight minus the weight we're looking for is equal to 2/3 pi, and then r is our radius, and our radius is 6378. Okay, but the radius would then be minus delta x, because we're trying to find, because if we're removing a slice of it, the radius, it'd still be, oh wait, it wouldn't be a hemisphere anymore, because it's not, oh, that's no good. So we can't use this. Volume of a, I don't know, section of a sphere. Is there like a generic formula for like the volume of a spherical cap, I guess it's called on Wikipedia here? Portion of a sphere cut off by a plane. Yeah, that's good, that's what we're after. The volume of a spherical cap may be calculated using radius r, radius a, and the height h. Yes? Okay. So I think, so we definitely want to be using h. Okay. I think we want that first one. So that would be v equals pi h squared over 3 times 3r minus h, right? And then h, h is gonna be 6378 minus delta x. Alright, so we can put that in. I guess that'd become a plus delta x. Okay, and we can put that up here as well. Oh, hi Zilla, hope you're doing well. I'm doing my, it's not really homework, because I've essentially invented a problem to give myself, but, hopefully it'll be good to solve, and I'm very sorry that I'm taking so long. Proof that I'm bad at calculus, huh? H squared would be, I guess we'll just write it like this. Minus delta x squared Okay. So that's the mass. We actually don't have any unknowns left in there. So, and we actually don't have any unknowns left anywhere, which is great. Yes. So, minus that amount would be, our density is 5515, okay. So that's 5515 kilograms per meters cubed. I'm gonna stop writing it in for now because I don't care enough. Times pi times, I guess I'll expand this just, well, we won't expand it just in case. And also because I don't want to. So that's 6378 minus delta x all squared over 3, and then times, and then times 3r minus 6378 plus delta x. Okay. And then, let me just like move stuff up. What's on this layer? There we go. So then, negative circle equals 5515. Here, we'll simplify a little bit if we can. So 5515 pi times so that's 6378 minus delta x squared over 3. And then all of this is times, I can put this in parentheses because why not, 3r minus 6378 plus delta x, and then it's going to be minus 299, or 2.99 times 10 to the 24th. Okay. I guess the parentheses don't matter, like, at all. And I guess the positive version, well, yeah, the positive version here is just going to be the negative version here, and that is times all of this, so that is fine. Oh my goodness, we're almost at break time. That is not a good thing. I'm taking too long. I just would really like to solve this. So the only problem is that we have an R in here still, right? 2.99 times 10 to the 24th, then minus all that now. And I do see why I was about to. 6378 minus delta x squared over 3. I guess times 3r minus 6378 plus delta x. And like that. Okay, I guess I can expand things just so I can then simplify. So 6378 and minus delta x. Heh. So I'll do that up here, right? So we have 6378 and then so we have 6378 squared, 6378 delta x, or two of those, yeah. And then delta x squared. Okay. So, oh, this part is negative. Okay. So we have 6378 squared, which is going to be a big number, and we are going to abbreviate it as I don't even know what to abbreviate that as, to be honest. It's just big. So we'll call it 4.067 times 10 to the 1, 2, 3, 4, 5, 6, 7. Okay, times 10 to 7. And then minus, if we multiply it by 2 instead of minus 1.277, I guess. 1.277 times 10 to the 1, 2, 3, 4. Wait, what? 1, 2, 4, yeah. And we'll add a little thing there so we know that's 10 to the 7. In fact, let me just write these numbers better. They're getting a bit small. And then plus delta x squared. Okay. All right. I actually don't like that, so I'm going to not expand it. What do you know? I just don't want to. Trying to find the best way to simplify, though. I mean, my favorite way would be to solve for r here, and then we could do something about it. But it's fine, I guess. So with this, we basically, I'm gonna like shrink away a bunch of stuff real quick so that it's not in my way. Oh well. That'll just get shrunk with it, I guess. Put that up there. And erase and fix and erase. So if we have our thing here, this is the volume of a particular slice of the hemisphere, right? Right. And every slice is going to have a so every slice is going to have a gravitational pull. Okay, that's a little tricky. 1 hour of nerd, golly, huh? So if we have the weight of a slice, not the weight, but we have the mass of a slice here. And I guess if we just make life easy on ourselves, right? I'm going to make a dumb assumption because I'm not a physicist, but we're going to make a dumb assumption and we're going to assume that the total gravity, and I guess that's technically a vector, but we're only really looking at it. Total gravity as a scalar, I guess we'll write, equals, 2 equals, 9.86 over 2. And that is 4.93 meters per second squared. So if we're making this assumption, then here, what I think I can do is say that each slice, right, each slice accelerates towards the center here, at, well, actually, hang on. So this would be the, this is like different E. So if I assume that, I'll give a circle, and then smaller. So, and then erase. I'm very sorry that today's gone so differently than planned. I just would really like to solve this problem. Basically, from the center of mass to the edge, or to any given point, really. So, we'll call that, like, I don't know, R works. Or maybe not R, but like, squiggly line. Squiggly line equals, so squiggly line equals that it's a vector, right? Pointing towards it. and it is 4.93 meters per second squared. But that is made up of two components, right? An x and a y. So we say theta is there, or we'll put it over here instead. We have theta and then cosine of theta and sine of theta. Sine of theta here will always be cancelled out perfectly by whatever is below it, right? Because every point up here has a corresponding point down here that cancels out that verticality. And the same goes for the z direction that technically would exist, right? True, yeah. Not cute. So we can really just worry about 1/8 of the sphere. Which is like half of the hemisphere, if I'm remembering right. Either way, it'll be fine because it is the same in all directions for an angle around that. Kind of almost, though. No, it's a quarter of it, okay. Since when did Twitch have replies? It's been a while. I don't know. I feel like it's somewhat new, but it's still definitely a thing. But we can just worry about the cosine there, basically. Right? Or not, it's not the cosine that is, it's the, here. Y and X. And then cosine of theta. That's still poor music, it's just a different track. Let me show you. You see? So cosine theta is going to be equal to x over 4.93, right? And that's true of every point on this. So points that are in line, like this, are going to have 0, basically. Or rather, cosine would be 1. I guess... Hang on. So... How am I finding this? You have the distance there, and always? I don't know, under Jupiter properly. Ollie. So... I guess technically it would be m cosine theta, because it's the mass of the point times cosine theta. But basically, what I'm figuring here is that equals, I guess we would multiply by m over here. Okay. So here we have the force of gravity on a slice. Right? Right. Then... I think. because x is the distance to the center. Right? So x is the distance to the center. And then that's how that works, I think. Maybe? I don't know. But what we can then conclude, I really don't think I'm going to be able to integrate this. Or even really simplify it. The numbers are just too big. But I want to figure out. So, force of gravity pushes that way on anything on this half. So if we integrate, I don't want to deal with theta. I wish it were in a variable I already had. Ah, my goodness. Actually, we don't need to worry about theta. I mean, we do, but we don't, but I don't want to. I don't know. Basically, we need to find... Yeah, this is correct, I think. Because this is how... So this is... If we just, like, put in this dot here for m, then we would have the force of gravity for a particular slice here. What is r? Is there a way I can substitute it out? I don't think so. R is the... So, the radius of the sphere is r. That means that it would be constant, wouldn't it? That's actually brilliant, huh? Okay. Because that means that this r here it would be a constant. Let me put that in. And specifically, it's the radius of the Earth. No, yeah, the radius of the Earth. Which also does happen to be 6378. Awesome. Which means that this actually... We can just simplify this to be 2r. Alright, and then we'll just put an r everywhere we see this number. That's so awesome. Okay, so we'll put a big old r equals under that. So, yeah. This should be correct. So, force of gravity on particular slice in that direction. The cosine of theta. What was that again? Well, actually, we don't need to worry about cosine of theta because we just worry about the horizontal distance from there. And that was already delta x, wasn't it? No, delta x was the thickness of the slice. We can't get those confused. But x is going to be the horizontal position. Alright? And that's a negative 3,986.25. Okay. So, then, GGST. I know, Timmy, I'm so close, I promise. I really didn't intend for it to take this long. I'm so sorry. So it's x over... Yeah, I know, I'm sorry. So, the force on a slice is equal to, or at least what I'm assuming is, because this is making a ton of assumptions and it's not even great, and I just would really like to see if I'm anything close to correct anyway, but I don't know how. 4.93 times this essentially. Watching this for sound while watching my friend try to golden chapter 6. I tried some golden berry earlier today. I got like almost all the way through the hotel. I'm just really bad at Celeste and getting golden berries. Yeah. So we basically need to find a way to move these delta x's out of where they are. You know what I mean? Because we can't integrate if they're so involved in the problem. Can we? Probably not. Yeah, definitely not. So that would be 5515. I'll just substitute 5515 for the letter D for now, since it's going to be easier to keep track of. Density. I'll keep track of that, like that. And then 2.99 is going to be, I guess, our big M. Alright. So, what we have here is, we'll have a R squared, then a minus 2 delta x, and then, oh no, minus 2r delta x, then plus delta x squared. I'm not so certain I can deal with a delta x squared. I don't think that's allowed, but we will see. And then we have the density times pi here. So we have density times pi times r squared minus density times pi. Whoops, that's wrong. Density times pi times r delta x plus density times pi times delta x squared. And that's all over 3. Hang on, let me move this over. So this is all over 3. And then it's all being multiplied by 2r plus delta x. Okay. So that means this one becomes d pi r cubed minus d pi r squared delta x plus d pi r delta x squared. Wait, hang on. I'm doing this wrong. Oops. That's a binomial, which does suck a lot for me. I will have d pi r squared minus d pi r delta x plus d pi delta x squared, and then we have 2r and delta x. So we have 2d pi r cubed, then minus 2d r 2d pi r squared delta x plus, or a positive here for 2d pi r delta x squared. Okay. Then we have delta x, d pi r squared delta x, and then negative d pi r delta x squared. And then over here we'd have d pi delta x cubed. Okay, any like terms? D pi r squared delta x. We'll cancel out one of those. D pi r delta x squared. We have a d pi r delta x squared here. So we'll cancel out one of those again. And then there's not really anything else that can cancel with. So we're going to, wait. Yeah, so it's 2d pi r 3, r to the third, then minus, delta, or density pi r squared delta x plus density pi r delta x squared, and then that's done, and then I guess it would be plus d pi delta x cubed, and then all that is over 3. Now what can we do with this? I guess it's still m minus all this. We mustn't forget. So I guess we can split them up into their own fractions and see if that helps anything. We have 2d pi r cubed over 3. We have minus d pi r squared delta x over 3. Then we have, not cute, Grace, you silly, d r plus d pi r delta x squared over 3, and then plus d pi delta x 3 over 3. Okay. So, I mean, I guess we could actually, so when you think about it, d pi and r are all constants, right? And oh, but there's more in there. Golly, let's move this up. like to there. Goodness. So we can, I guess, factor out d pi. Even, no, not d pi r. We can do d pi over 3 times 2r cubed minus r squared delta x plus r delta x squared plus delta x cubed golly. So if we were to just, because we can't factor out the delta x is the problem, you know? It's just not happening. And there's still technically m minus all this. So maybe we see what Wolfram Alpha has to say. Because technically speaking, I don't have to solve this myself, and it doesn't seem like it's in my capabilities. So let's see. We want to say integrate from 0 to... It's not AI, it's existed for a while before that. And it is a math tool. Integrate from 0 to 2391.75. Or here, what I can say is definite integral 0 2391.75 or maybe we'll put it into Wolfram Alpha as a Riemann sum. So that would mean we put a limit as n goes to infinity. Do we have a symbol for that? Yeah, as n goes to infinity, the summation, so I equals, I guess, 1, and then so let's see if we can go x over 4.93 times, and can I have m's and constants in there? I hope so. But just in case, I guess I can't. Maybe? I don't know. hang on, we'll do parentheses here. M minus, and then another set of parentheses. B pi. I guess I have to use a symbol for pi. D times pi times r minus. Do we have a symbol for delta, I wonder? We do. Capital delta. Minus delta x. And then this section here over 3. And then that section times 2r plus delta x. Okay. Can I perhaps have... Does it have like an x sub I could have? Something like... Well, maybe we enter and see what it says anyway. It might take a moment. Doesn't understand. Fair enough. Oh well. What time? We're at an hour and a half? Okay. What I'm gonna do is, I'm going to take a screenshot. Whoops. Of this. And then I will just close this without saving. Actually, I do want to save it. Math work 1, sure. I'm very sorry about all that. I will be... Blah, 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 blah. I'm gonna take a little break really quickly. Sorry. And then we'll do Guilty Gear after the break. Drink water, I will. Okie dokie. Alright, yeah. Now I'm gonna open up Guilty Gear, and if any y'all are still around, we can play. My goodness, I'm so sorry about that. I just really didn't want to let the problem drop while I was thinking about it. Probably should have, I guess. Oof. That took way too long. And I didn't even really get an answer, unfortunately. And I didn't even really explain myself either. So, it's for the lore of my video game. Essentially, the orb thing is, so ages and ages in the past, I don't know how long, so don't ask. A powerful wizard cut the earth clean in half, and so it's going to be, not really a major thing, but, somewhat minor thing, to mention that a great deal of magic is, or not even really a great deal, but a good amount of magic is being used to just keep those two half-Earths separate and also not, collapsing at all. So I was trying to calculate the force that would be required to prevent, an object with that mass from collapsing into a sphere, basically. And my approach was probably not the best, but I figured I'd be able to, basically just add up the force of gravity on each, like, circular slice of it, and then, basically, in the vertical direction, each point has a corresponding point on the opposite side that cancels out the vertical component of gravity. So we could basically just worry about how far it was from the center of mass, and then that is the wrong thing. And then once we found out how far it was from the center of mass, we'd know how much, we basically know how much the part on the left would be pushing against the part on the right to basically, like, start crumpling it back down into a ball. And I did the wrong thing again. My goodness. Because in my head, if you have, like, a perfect hemisphere, it would be ba 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 ba, you cutie. 7777. Did you make did you make a lobby, or are you just putting up the code? But in my head, the way it would work if you had a perfect hemisphere is that material, or, like, because the center of gravity or the center of mass is just being a good mod. Thank you. Because the center of mass is unbalanced basically for the object. In my head, the part with more mass would be pushing on the object more than the part on the other side of it. So it would be like, and then it would come down and stuff from the ground. And golly, I can't even say words proper. But basically, my idea would be that if you're just counteracting that force, you'd be preventing it from collapsing into a sphere, kind of. So, yeah. Because it's not like you have to make up for exactly the other half of the Earth, right? You'd have to just basically... I mean, you would if you were trying to get gravity to be the same, but I wasn't. So, it's tricky. Oh golly, I am not at all in the right headspace. Oh golly. Oh golly, not held the right button. Uh-oh. There we go. Whew. Golly though, I feel so awkward about doing all that math at ya. Don't you know, Timmy, that's a safe jump. No, stop that! Okay. But yeah, I just would really like to know the force required so that I could drop it in the game as an Easter egg, you know. Like, yeah, this isn't even my full power. I'm using, like, 6% of it on keeping the two halves of the Earth from, both. Boink. Not what I meant to do, but it works. Oh, golly. No, no. My goodness, I have work in the morning, too, is the worst part. I'm gonna be eepy. My cat. What about your cat? Was Luna in the way again? Is that your excuse every time, forever? Was in the way? Oh, uh-huh, uh-huh. How silly. And was getting into food. Oh, that does cause problems, yeah. I'm hungry. Oh, golly. Oh, darn, you got sent away. Oh, golly. Oh, no. Whoa. Darn. I was hoping. No. Don't counter? Darn it. That's worse. Owie. Go away. Ahaha. It works like a charm. Ah! Haha. Yowie. Ooh, gotcha. Yowie. You silly Zilla. Yeah. Approved. You're way cooler. Oh, did not mean to grab there. That whoa. Oh darn! If I'd been mashing, I maybe could have. Gotten it. I waited for it, you know. Never forget that my, I don't know, 2 something, 2H. It's big. Oh golly. Go away. No, stop it. Uh-oh. Oh darn, I lose. Painful. Hooah. That is not the right input. Jump. Darn. I really was hoping. Estimate. Uh-huh. That is correct. That is who that is. Oh darn. Darn it. Go away. No! I was going to run up and grab. You shouldn't stop me. Whee! Aha! Yes! Anyhow, hi nuclear lunar. Hope you're doing well. Smiles. I always forget that I can't, like, look to the side. Like, I can't purse my lips to the side in a, thoughtful manner. Like I used to be used to be honest. Because on this tracker, it comes out as an angry face, when it's really meant to be a thoughtful face. It's silly. You love Testament? How nice. Your buttons are not buttoning. So your cat was in your way, your buttons aren't working. What else can you come up with, I wonder? I don't understand. Not my main. This and that, yeah. I don't know what Grace is referring to be honest. I have to get an explanation. Ooh. Oh, whoops, I meant to be doing... Grrr. Darn it, that is not according to plan. I didn't even intend to scooter there, if I'm being so honest. It just happened. You know what they say. Yoink! Hey, that's rude. Go back there and die. Thank you! Smile. Hey. Ah, no. My one weakness being slightly too far away. Oh, no. Darn it. Never punished. Ah! Never punished. Never punished. Never punished ever in my life. Hehehe. Now then... I really, golly. I've got to remember to do homework tomorrow, and a lot of it, because I worry that I'm missing, like, everything ever. At the end of the first week of the semester, I'm probably missing 12 billion assignments, so gotta catch up. Whoopsies. Whoopsies. Aha! It works? Yes. I'm always so bad at doing the inputs when I'm facing this direction. Oh, darn. No, go away. Ow. I didn't realize my health was that low. Whoopsies. Ooh. Golly. Golly! I'm really letting all this happen to me, huh? What? I missed? Oh, go away, grr. Uh-oh. That's no good. Technically speaking, I should have been on the other side, you know? Like, I should have been already past your move because I was that... No, you silly. Golly, what time is it? It's 11:24. Alright, we'll try and do maybe another half-hour stream if we can muster. Usually I cannot. Whee! Whee! Oh no! Ooh, you tried it! Bonk. Aha! Oh no! No, no, no. No! Check this out. I'm facing the wrong direction. But it works! Never punished. Ever. In my life. I think it's that, like, the second part of the attack saw that it needed to be on the other side of you. So someone who spins punishment. Okay, but... Doesn't count. We clashed? Oh, is that what happened? You switching characters or doing something else? Autumn Kim time. Personally, I think that Rock the Baby should have exactly the same interaction with Autumn Kim Buster that two regular grabs have, where we both get sent back a bit. That's just my personal opinion. Oh, darn it. Oh, darn it. Oh, darn it. Oh, oh, oh. Uh-oh. Go away. Oh wait, I'm... No, no, no. No, no, no. Tune in next Saturday. Oh. I didn't know it was still active there. Golly. I probably am just dead. Ouch. Stop. You silly. That was you silly. Wee. Hey there, wife. Ah. Aha, multi-hit. Oh, darn it. I wanted that to not happen to me. No. No. Go away. Ah. I win these. No! Flick my hair back and forth. You silly. I don't think you should pull out the spin to win strats against Timmy. Like what? I'm a little confused. What are you talking about? Darn it. Bonk. Gotcha. Ooh, you tried. Oh, no. Bit of a lag spike in there. Boom. Uh-oh. Explode. Die. There we go. Bridget doesn't really have any combos that make you want to uninstall the game that I know of. Getting put in the blender usually makes you unhappy, but it's not like an uninstall mode like with Pumpkin Buster. Oh no! Die! Pretty please, walk into it, No! Darn it, I wish that worked. No. Ugh. I like that trade. Oh darn it. No, go away. No, stop that. Oh darn it. No, darn it. Tragedy. Tragedy. Aha. No! Go away. No, I hate that move. Heh heh. Heh heh. Oh no! Ah! That's my bad, yeah. Oh, how very silly. I guess I have to reinstall the game just so I can uninstall it, huh? I never said, well, I might have said at one point that I was good at the game, but I was wrong. Golly, I just like this model, I don't know. Sometimes it just... Stop it! Go away! Go away! Go away! Go away! No! Ah! Your arms are too long! No. No! Golly. Gah. Gah. I'm too tired, I think. Ah. No. I really don't like that aerial move. It's just too good. Oh golly, no! What the heck? That's just mean to me. Goodness. Golly. I'm getting real eepy. You got played. Just a little. I wasn't even trying to block there, I'm gonna be honest. Outskilled and outsmarted. I think it was kind of neither, personally. I really did not do an optimal punish there. Oh, but this will be better. Oh no, never mind. Yeah. No! Oh, I'm dead. Where? Golly. If your legs were normal sized compared to the rest of your body, you would have... I would be able to hit you more, you know? It just happens that your massive biceps have become, like, pole arms for you. No! Never skip leg day. Yeah, go away! Go away! No! I hate just losing in that situation. We both pressed the button. Oh. Golly, what time is it? 11:36, huh? Goodness. Beansy Beansy EP. I'm not Beansy Beansy at all. I'll have you know. Bigsy Wigsy, they call me. Excuse me. Golly. Bigsy Wigsy EP. Bedtime then. I mean... I don't know if it can be bedtime just yet. We've spent not nearly enough time on Guilty Gear, you know what I mean? Die. Did you like that? I cancelled the scooter with the thing. I've been trying to remember the timing on that. Oh cool, you can do it similar. That's neato burrito. Yours didn't work though, so. Darn it, I was gonna grab you. Without shame. Aha, I knew you would if I just gave you a moment. Predictable Timmy is what they call you. Lag? Yeah, I felt the lag too. You're not special. No, I'm joking. Goo. No, stop that. Grr. You get so much damage off your combos. Oh golly. Gah. Golly. Golly. No. That is the wrong button. No. Go away. No. Mean to me behavior. No. Meanie. Bleh. Bleh. Golly. Yeah. Golly. My brain doesn't work anymore, I think. Oh golly. Goodness. Wrong button. Whoops. Go away. Why don't you uninstall now, Timmy? I predicted you. Incredibly. Golly. Holy. Oh golly. Oh golly. Oh yeah. Golly. Sorry I don't have much to say right now. My brain's just like melting, you know? Maybe. 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 Golly. You'll play someone I'm bad at? Ow, 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 ow. EP Sharky. Wow. Cute. Wow. No, not me, Timmy. Sharky. Both. No, no, no. Wow. Wow. Golly. Mm-hmm. Whoa. That's new. Never tried that before. Golly. Oh, okay. Golly. Ooh. No. No. I think maybe I end stream here. Mm-hmm. It's 11:46. Wow. You are EP. Yeah, I think that's why I'm thinking I end stream here. I can't play game. Unless I switch to a much lighter game, but, I mean, I have work in the morning anyway, right? So, you know, might as well raid out now. What time? Yeah. Night-night. Yeah, we'll raid here again. Bye!